and today I'm going to run through a few undergraduate, upper high school level chemistry questions. So here's our first one for today. Separate this redox reaction into its balanced component half reaction. So I'm just going to rewrite the reaction here. And we know it's a redox reaction because on this side, the charge on chlorine is 0. We can check the formal or the oxidation state on each of the constituents by just comparing the total charge and using some of our rules. So here, because chlorine's a pure substance, it's going to be 0. Here it's just sodium, so the total charge, it's going to match the total charge, which is 0. And then here we've got NaCl, and halogens will typically be -1, and alkalis will typically be +1. So that's going to be the formal charge there. So we've got a change in charge state, and that is what happens during a redox reaction. So to split them into their component reactions, we split up the 0 to -1 and the 0 to +1, or as they're called, we split up the oxidation reactions and the redox reactions, or reduction reactions. Okay, so once we've split them up like that, we balance them by adding electrons to the appropriate side. The side that we add the electrons on is always going to be the same, no matter whether it's the oxidation or reduction. So for every oxidation, it'll always be on the same side of the reaction. But just for explanation purposes, the side we're going to add it on will always balance the charge. So on this side of the reaction here, we have 0 charge. On this side we have +1, so that means we need an electron. And here we have 0 charge, and on this side we have -2, so we need +2 electrons. And then when we balance the redox reaction, we need to balance the number of electrons, so that means this guy needs to be multiplied by 2 throughout. The clue, of course, was given in the original equation anyway, but that's okay. And then we just sum the two reactions, canceling out the electrons where appropriate. So here we're going to cancel 2 with 2, and we're going to sum them and get 2Na plus Cl2 goes to 2Na plus 2Cl minus, which is basically what was given in the original expression anyway. I just wanted us to separate them. So these are the two separate equations. So that's the oxidation reaction and that's the reduction reaction. And just to be sure that they're visible, so there's our oxidation and our reduction. And we're assuming it's in neutral condition, but it actually wouldn't matter if it was in acidic or basic in this case. Okay, so there's our reduction, and our oxidation. So this looks correct. Yeah.